2 times ago, I think, 3 models that showed how to read things in from network files. Do you remember that? And one of them was called hard-coded minimalist network, ABM or something like that. I'd actually like you to open up that one, okay? And we're going to basically add these controls to it, to that model, which will include an edit box for text, include radio buttons, and it will include a file chooser. Okay? Being able to choose our own files through a dialog box. Okay, so once you've got that model open, hard-coded minimalist network ABM model, I'd like you to add a parameter here, which is going to be called network file path and name. Okay, so it's a network file path and name. So it's in other words, we're going to have some network file, and we're going to be encoding its so-called path, where you go for it within your computer, and it's file. Okay, so this is going to be called parameter is going to be called network file path and name, and it's a string. Okay, it's going to be a sequence of characters. Okay, so that's a parameter type. Most parameters we've dealt with thus far are doubles, ints, booleans. This is actually going to be a string. It's going to tell us where to go to find that file, the network file that we're going to be reading. Okay. So we're adding a parameter there. Now, in something that I'm going to explain a little bit more in my next lecture, today's session, we're going to be using something called an enum here to encode what sort of file it is. Is it a PIAC file or is it a connectivity matrix file? Okay, you can think of this as defining sort of a custom type. Custom in the sense that, in contrast to built-in types like booleans or doubles or ints or characters, which have a fixed number of possibilities that are delineated by the Java language, here we kind of define our own name for, our own names for different values, and we give a name for kind of a member of those values. So we can have something called a PIAC. Here, PIAC file type, or a connectivity matrix file type. And we could call the set of those things network file type. Okay? So you can imagine, if you think about other contexts, this might be male, female, and this might be sex. Or this might be ethnicity, and this would be a set of ethnicities. Or this might be cities in Maine, right? And you could have a set of cities in Maine, or what have you. So basically it allows us to define sort of a set of possible named values. And this is in reference to when you have something of type, network file type, it's got to be one of these, either of these two. Okay? Either you have a PIAC file or a connectivity matrix file. That's what we're going to be dealing with. Okay, so AnyLogic doesn't have a built-in thing to declare an enum. So where you have to put that is you have to go up main, down main, and you have to go to advanced, and you put in additional class code. And what that's going to say is, within main, it's going to know about network file type now. It's going to know it's either PIAC file, connectivity matrix. Note the semicolon at the end. Okay. The other thing which we're going to have to do in here is we're going to be using some, in fact, I think this is, I can't remember if it's in here already or not. In the import section, is there something that already says import java.io? There is, okay. So that's basically saying we're going to kind of bring in a bunch of know-how from this so-called Java library, java.io. Okay. Very good. So that was there, I guess, already, and make sure it's in yours. But this enum is the most important thing I want to draw attention to. It turns out enums are really useful. Okay, and we'll see a little bit of the twist. Among other things, if you have a value that's an enum, so let me ask this: if there were no enum supported, as it was when I was young, how would you encode this? What's another way you could encode this? If you didn't have the luxury of giving it a name, what would you encode it as? What could you encode it as? Okay, you could somehow do an array. Yeah. How do we commonly encode sex within, a SAS file? You might encode it as 0 and 1, for example, right? The problem with 0 and 1 is that 0 can mean different things in different contexts. It can mean Alaska, in a dialed states. 0 can mean male, in the context of sexes. It might mean the 0th income decile in other cases, or what have you. This allows us to give it a name. And very importantly as well, if we have some data within the model, say a network file type might be an example, maybe it's a sex or ethnicity or what have you, and we go to print that out. If it were just a number, it would print out as 0 or 1. Here it will actually print the name. It will say, this is a pipe file. This is a connectivity matrix file. It actually knows how to sort of print out a proper name when we have a piece of information like that. And that's useful. It's also useful because we can actually write down in our code Payek, and it actually knows what that is, in terms of, okay, it's a value, it's one of these guys. And it prevents us from just assigning it a 0 from who knows where. So actually, being able to name it like that, it turns out to be a useful thing. We'll see another twist or two about it. Okay, so I'd like you to now create a parameter that's going to encode the network file type. This is going to be a parameter within our model. And this parameter, ladies and gentlemen, is going to be of type what? We're going to use it to encode what type of network file we're dealing with. What type should I associate? Is this a double? It could be a string, okay. But we've actually just introduced it's an other, and it's a network file type. This thing here. Now, here I could probably do without main dot, but you probably just say network file type. I can't remember why I made that, but this is technically true. It's the network file type that lives in main, because we defined it in main. This was in main that we defined it inside of this. We said network file type, but I think you may not need this main dot. It may just be network file type. So that's the type of this. In other words, this parameter holds one of two values. What are the two possible values you can hold? We don't need this. Payek or connection matrix type. In other words, this parameter, some parameters hold double, some parameters hold int, some parameters hold strings, some parameter might hold color. This parameter is going to hold a value, one of two possible values, Payek or connection matrix. Does that make sense? Okay, so this is going to hold that. Okay, good enough. Now, if we go over to simulation, to the experiment here, what we're going to add in, now this is where, I forgot to give this to you. Okay. Maybe you just look at the slides from now on, unless you have this on your computer, it's probably on your computer. I just forgot to tell you where to find it. There's a library called Swing Layout Library. Okay, this is a library that is a Java library. It's very common. You'll find it around. You can download it for free. It's provided with Java, and there's a file called the Swing Layout .jar. This is a Java archive, and that basically contains a lot of code to do things. And one of the things it will support is things to choose files. Yeah.
What exactly is Java Archive?
Okay, Java Archive is a collection, bundling up of code in Java. I'm gonna throw out a few terms here, and these may not make sense to everyone. But when I take a Java file, okay, call it x.java, okay. And there's actually a bunch of Java files here. If we look, watch this, ladies and gentlemen. So if I go here and I go over to here's this UI hard-coded. If I right-click on main, first of all, let's build this first because you want to make sure it's been built. Okay. If I right-click on main and I say open with Java editor, I'll see a main.java. Okay. We saw this actually last time. You can't edit it, but you may want to, from time to time, peek at it. Okay. So there's for our model here, this main.java. There's a person.java. There's a simulation.java. Okay. So really, your high-level description of your AnyLogic model with its state charts and its events and its various functions and so on. Really, behind the scenes, all that gets transferred into Java files, right? Now, when you do that so-called build, so we have this bunch of Java, it produces a Java file, but it goes a step further. It actually turns these into what are called class files. Okay? A class file, so these guys here, these Java files, are like what I just pulled up there. So if I right-click on this and I say open with Java editor, it's a bunch of text, right? It's a bunch of text. That's not a particularly efficient way of encoding it. It's not. If it had to interpret that in order to run it every time, it'd be doing an awful lot of work just figuring out like, oh, okay, this is a W, and then an H, and then an I, an L, and an E. That must be a while statement, right?
Is that compiling?
So this is the compilation part. This is the so-called compiling. I mean, you could call this a sort of source-to-source compilation, but this is the core compilation. So this goes to a person.class, and this goes to a main.class. These are the same information that's in there by and large in that text file, in the Java file, but it's there's some additional information that's joined in, and it's in binary format that's really quick to execute. It basically doesn't have to, every time it sees a while statement, it says, "What's that, Sonny?" Oh, it's a while, W-H-I-L-E. Oh, that must be a while. It doesn't have to do that job. Instead, it just knows that's a while. And it can execute it very, very quickly. It doesn't have to figure out what things are. It just kind of does the work for each one very quickly. There's some additional information, but that's a lot of the gist of it. So these here, I can take my class files and I could give them to you, okay? And I could give them one at a time, and you could run them. And importantly for Java, one of the significant aspects of Java, significant advantages of Java, is that I could take a class file created on your Linux machine, and I could run it on a Windows PC, or I could run it on, an older Mac or whatever. I could run it on all these different machines. These files are machine independent. They can be passed around to all different machines. So if I wanted to distribute my simulation model to develop, I could give him each of my classes and he could run them, but that's kind of tedious. I have to transfer a bunch of files. Instead, I put them into a jar file. So a jar is just a packaging up of these class files in a way that kind of makes it easy to distribute.
And once you have the class file, you can access the source code
correct, short of something called decompilation, which is sort of taking this and trying to figure out what might this have looked like to turn into this. It's kind of reverse engineering it. And there are tools out there which will do that. You generally run afoul of licensing agreements and so on when you start doing that. But generally speaking, I mean, you can kind of figure out, okay, this was a while loop, etc. But it's an imprecise thing, actually, because certain things might have gotten stripped away. Like, it may have realized certain code here can never be reached. Like, if you had an if false, it might just totally strip away this thing and you know, basically just wipe all this out because it knows this is always going to execute. So you're never going to get back the full. You're not going to get back the full thing there typically. But these class files are packaged up and they go into a jar file. And that, ladies and gentlemen, is what I was referring to. Whoop, I'm not, okay. That was what I was referring to here. So there's a thing called swing layout, which is basically a Java library with some components in it. Now, I could distribute this to each of you, and I probably should do this, but because time is moving on, maybe just pay attention here, and you could see if you could follow this at home after I distribute the file, okay? You could try this one at home. Okay, so the next thing you have to do is you have to say, okay, so I have this swing library. I want to use one of the things. I want to use a J file chooser. I want to be able to use this component to choose files visually. Okay. You notice I'm trying to do away with the need to use this one from AnyLogic. I'm trying to use a general one. So then I added a button that's called select file. You could actually do that if you want. You could add this button, select file, and then I added an edit box here. Okay, where I give the edit box a name, and I added a label for the edit box. It's a static label. It says network input file, and then I add some code here for the button here. So I have a button that says select file. And when it pushes the button, it basically creates one of these J-file choosers. It opens it up and it shows a window. And I can then go and get my file. And if the result of that is that I want to go forward with it, basically it will set its path to file name in this thing here. So it will kind of put its name and where its location is. So let me just show you what that looks like on my screen, because it's running here. So run, here we go. Okay, so if I do select file, this will come up with something along those lines, and I could go to my classes here, and I could go to example models, and I could go to these things, and I could pick my PIAC file, okay? So you'll notice when I did that, it put its information here, okay? Now, by contrast, if I had done select file, and I gone to that same thing here, and I had selected instead, if I had just done cancel, it wouldn't have done that. And that's why there's some code here. I call up the file chooser, I show it, and then if the result says the user approves, in other words, doesn't cancel, then set the text for this guy to be whatever indicated in the current directory from this file chooser, appended to whatever the name of the file is that's chosen. Okay? So in other words, I call up this file chooser. If the user said OK, I'm going to get the information on what file the user chose, append it to what directory it was in, and set that up here. Okay? So that is going to be set within this box here. And so this is using that file chooser, which is the thing referred to by the by this guy here. So basically, this thing says, okay, where to go get this library. This thing says, okay, from that library, what thing do I want to actually reference within this class, or which things within that library. And then this is the code to use them. And then I have some buttons here. And you could add these if you wanted to. So basically, you have to go over to radio buttons, drag them in. And the radio buttons, you can set a couple choices, many choices, in fact. And so you can type in here, for example, PIAC file, and it will have an option for PIAC file. You can type in here connectivity matrix file, it will have an option. This is just a name. It doesn't know what that means, but it gives the user a label here by which to choose, okay? And you can do as many as you want. Here we're just going to do 2 of them. So here we have a label. And if the user has chosen this one, it's going to be encoded with a 0, and this one is 1, and if there are more, 2, 3, 4, and so on. So the value of this radio button is going to be dictated by which one the user chose, and it starts at 0 and rises after that. So now, ladies and gentlemen, I showed some code for this, which called up the file chooser and set the value here, if the user said OK. So that's the path to the file. If here I'm choosing what file type it is, if I wanted to communicate that information, the location of the file in name, and the type of the file, if I wanted to communicate that to main, how would I do that? Through what? How would I communicate from the experiment to main? We've seen it before, so about 15 minutes ago in the other model. How would I do that? How do I communicate information from a simulation, from this experiment to main? I do it through parameters. Yeah. So all I have to do is do it through parameters. So I have 2 parameters within, in fact, we created them earlier, remember? Just a few minutes ago. Remember we created this guy and this guy? Network file type. It was, so network path and file name, what was that? It was of type what? It was a, the network file path and name was actually a string. Network file type, by contrast, was a network file type. It was the enum that we created. That could be either a what or a what? A PIAC or a connectivity matrix. Yeah. Okay, so this is how main is just waiting to be told what file to use and what type it is. So now we're in a good position to do that because we have these controls we added here. This tells us where to find our file. This tells us what type it is. So we are going to, for the parameters, have just whatever's in this edit box, whatever's in here, we're going to use for the file path and name. And whatever is here, whatever is selected, we're going to use that particular item from the enum. So if 0 is used, it's going to use PIAC. If 1 is used, it's going to use connectivity matrix. And it does it by, you actually say main.network file type, this is the enum, dot values. That gives you, okay, the first is PIAC, the second is connectivity matrix, and you get the value from the radio buttons, 0, 1, 2. So if this is 0, if the 0th one has been selected, that very first one has been selected, it'll use the first in the enum, which is PIAC. If the second one has been selected in the radio buttons, it will use the second one listed in the enum, which is connectivity matrix. So in short, visually, if this guy is selected, it will use the first item in the enum. If this guy is selected, it will use the second item in the enum. And if we look back at how the enum is defined, the very first is PIAC and the very second is connectivity matrix. So it corresponds, in other words, the ordering of this is the same by design as the ordering of the enum. If we select only the first, it will use the first in the enum, pi-ec. Second one will use connectivity matrix. So this is actually the code to go from the two. This gets all the values in the enum, and it picks out the particular one that's selected 0, 1, 2, 3, selected by the radio button. Does that make sense? Yeah.
So, is there any other way to get the values from the simulation into the main other than using
Other than using parameters? Yeah, there are other ways too. They're not going to generally be quite as kind of elegant, but you could, for example, you could have it write out to a file, and main could read it in from a file. You could have it, I believe, while it's, you remember that button here, well, it's some time ago. This button here, when you press it, it does two things. Remember it said run and then set the presentable or something? You could actually have it like directly set variables in main at that point or something like that. So it can, so let's put it this way, Deval. This code here, like these things here, they actually remain, they're just not visible, but they're still running, I believe, at the time main's running. So in short, they could still communicate with main, I believe, on an ongoing basis. I'd have to double check that, but I believe that's the case.
And how does AnyLogic deal with a pi-ec file? Was that what came in the job file?
Oh.
How does AnyLogic actually know?
Okay, so that's a good question. So I've simply said here that there are these two network file types, okay? There's a pi-ec and there's a connectivity matrix. That is a great question. So how do I know I didn't say it's a snuffleupagus file or something like that? I don't know if anyone knows what I'm talking about. But so yeah, I mean, how do we know that's not a snuffleupagus file, right? Why does this mean anything? Okay, so maybe we accept my premise that when you select pi-ec here, that it's going to yield a value in the parameter of pi-ec. And when you select connectivity matrix in those set of buttons, it's going to yield connectivity matrix. But big whoop-de-doo. Like where does the rubber meet the road, right? Okay, so that is a good question. And with your permission, ladies and gentlemen, I will show you where the rubber meets the road. We will see the snuffleupagus. Okay. that may be. You'll be birdified. Okay, so this. There we go. The snuffleupagus is seen. The rubber has met the road. Okay, so we're in main. In the startup code for main, this asks, okay, from the parameter, what's my network file type? And this is, by the way, called a switch. I should have covered this as stateless before. It'll see, okay, what's my network type? And if it's a pi-ec file, it'll do these things. If it's a connectivity matrix, it'll do these things. If it's neither of those, we want to say, hey, something's screwed up here. I don't know what to do with the snuffleupagus. So for pi-ec, we want to call establish network transitions a population from pi-ec network file. If it's a connectivity matrix that we're dealing with, establish network transitions a population from connectivity matrix file. In other words, we're going to do different things based on whether it's a pi-ec file or connectivity matrix file. And that, ladies and gentlemen, is where the rubber meets the road. True or not? True. So this is where that becomes operational. Before that, it's all, okay, so we have these UIs, and the UIs translated to values, pi-ec or network connectivity matrix, but this is really where it actually makes a difference. Does that make sense?
Yeah, because I see the function.
Yeah, and those functions were there before. We were just calling them manually. We didn't have a good way to sort of figure out which to do. Now the user can actually select. I want a connectivity, this is a connectivity file, this is the file, and it actually goes and they can find it on the disk, etc. So it's sort of easier for the user. So, in this, you'll see the code is a bit clearer, because if this had been 0 and 1, like if I said this is called 0 and this is called 1, just use, I wouldn't have really known what it is and been confident it was Payek, but here we're sort of going for Payek. Now it turns out this can be done even nicer. I mean, I've purposefully avoided using advanced features of Java because I want it to be a little bit more understandable. But we could have an array that maps from these things to the corresponding functions to call, or just call to the array, and then we'd only need one line here. But this is just a little bit more easy to kind of follow the logic, I think. Okay, does that make sense? And because we've named them, we can actually refer in our code to these names, just like we could refer to, case male, case female, or a case, this state, or this agency, that agency. We can refer to it by name. And the reason it knows those names, how does it know these names here? By virtue of what, ladies and gentlemen, did it know those names, which have now disappeared? So those names, Payek, okay, so there were functions there, oh, there. How does it know? So these are the names of functions, absolutely. These are the names of functions, which were already there, actually. But this Payek, how does it know what that is? I told it in what? What was it? What was the thing by which I told it what a Payek is? Yeah, exactly, and that was an enum. That was an enum. It was by virtue of defining this enum right here that I told it what a Payek is. That there is a thing called a Payek. That there is a thing called a connectivity matrix. Absent that, I'd need to encode them as zeros and ones or something like that, and it would have been kind of messier, right? Because it would have said case 0, do this, case 1. It wouldn't have been totally clear, is a 0 really a Payek or what? Okay, does that make sense? Okay, so I know I stretched you a bit there and I have to provide that jar file. But the point is, what we've seen is a collection of controls here. We saw, early on, we saw a button. In fact, a built-in button in AnyLogic, a sort of button that comes automatically. We saw a slider. We saw a text field, both one with a fixed text and one whose text depended on the value of the slider. Thank you. And then subsequently we saw a checkbox, right? And then subsequently we saw a radio button, which allowed us to choose among a set of possible values, and we saw as well the edit box here, which can store basically text that the user types in. And we saw that we can set some properties of these at design time, but many of those properties are set are most useful at when it's running. So for example, we can ask the edit box, get me your text. And it will get the text, and we can pass that in as the value for the parameter. And that value, that parameter, could then, this could be a description of why you're running the scenario. You could put it to a database, or it could be a name to give to the file that will come onto this file, this scenario, whatever. So these are ways of sort of passing that information by getting information from controls. I've also introduced the notion of enums as an enumeration of possible values, possible legal values, so that you don't have to just encode it in a somewhat cryptic way using doubles or ints or what have you. And we've actually seen here, though this may seem a bit mysterious to you, how you can go from like number 0 and get the corresponding element in this enum. So 0 here would be pi x, 1 would be connectivity matrix 5. So that gives us a way of doing that. Okay? That makes sense? Okay. And finally we looked at how we could create a custom file chooser from Java's library, but I have to give you the file for that. Okay, so that was topic 1 for today. I'd like to talk now a little bit about types and enums.